Okay, so welcome to the final part. So it will be a very short part, so in which I'll try to outline current challenges and future directions of research. So during these 2 years, especially the final years, so we face certain challenges in data conversion and annotation. So one of the challenges is related to case compounding and stacking. So this is observed in certain Uralic languages and also Australian Aboriginal languages. So here is an example from the language called Kayalpil, which was described by Nick Evans. So this language allows to have up to 6 cases on a single noun. So here is an example where it comes from. So suppose we have a sentence, I gave the book to my brother's wife. So in that sentence, if we want to say it in Kayaldilt, so we will put wife in the dative, and then on top of that, we'll have ablative case. And my brother will have genitive, then dative, and then the ablative case on top of that. So, and this way we can keep stacking those cases on top of each other. And it's not entirely clear how we would annotate this language if we use UniMorph annotation schema, because it means we need to consider all possible combinations of the grammatical cases in that language. It means we need to get all these combinations as extra features in that schema. Otherwise, so we lose this information about the order, or at the moment, for instance, when we try to do the canonicalization of the data, so our script doesn't allow us to provide more than one grammatical case on a single, for instance, noun or adjective. So at the moment, we don't have a way to address this. So another problem that we have is clitics. So in some languages, we have some amount of clitics, like Russian, but in most languages, we do not provide the special paradigms for clitics. So clitics typically do not provide much more morphological information, but it's still useful to have in terms of this extra information, what might be in that language. But the problem with clitic is that for each lemma, we can generate an extra paradigm table with the corresponding clitic. So, and the number of these tables will grow exponentially if we decide to store all these tables. So the clitics, it's not clear how to store this information efficiently without just generating all these possible tables, because the way the forms will be changing, it will still be the same as this initial just lemma-based form without clitics. So it's not that much information. It's quite regular if we just add this extra clitic. So maybe we can use some rule-based approach for that. So in addition, we still have very limited knowledge in terms of how to approach polysynthetic languages and describe their paradigms. We have some polysynthetic languages, and we only have the most regular and well-formed paradigm tables for them. But it doesn't provide all the information about this, the whole richness of that language morphology. So, and of course, when we talk about polysynthetic languages, so we also need to mention that there's no binary boundary between derivation and inflection. So this is a continuum, and some paradigms in our data set still can contain derivations, For instance, in Russian, you would have participle formation as a part of paradigm, or masdars. And for certain ones, you might also have those derivation and inflection processes within a single paradigm table. So it means you would require multi-step transformation. For instance, if you think about English, so you would have something like for the verb to run, so you have it as a lemma form, but the target form will be runners. So, and it obviously requires not just inflection, but also this production of the agentive suffix. And derivation is not much addressed in the UniMorph. So we are still working towards that direction. So hopefully in the next year or two, we also incorporate derivational paradigms there. So another problem is this multi-word lemmas. So how we should store these lemmas? So because typically, if we do not consider the whole paradigm, so there is not enough information in the morphosyntactic features to say anything about the dependency and the relation between the words in these multi-word expressions. And of course, there's also always a question which features should be added. So when we try to update the UniMorph annotation schema, so we always try to think whether this specific feature is very language specific or language family specific, or we can use it for other families as well. So in terms of future directions of research, so first of all, we would like to develop a framework for proper error analysis. So we not just report this accuracy and Levenstein distance and perform some error analysis for individual languages, but we can compare the systems in terms of categories. For instance, we might have tests on allomorphy. What percentage of allomorphy errors we get with that systems? So of course, it requires more linguistic knowledge and linguistic information. So this is the idea that was also stated in other papers, such as by Elsner and Sims and by Rob Malouf. In addition, we would like to increase interpretability of the models and design and methodology to extract the patterns learned by the model. So at the moment, we don't have any methodology to understand what or which patterns do the models learn. Of course, ideally, we would like to work to make these samples of the languages more typologically plausible. And another thing to improve is to have a certain pipeline to augment UniMorph with new morphosyntactic features. So at the moment, we don't have that pipeline. We do not test how that specific feature map affects other languages. So, and another thing that would be great to have is this an approach to estimate how representative a paradigm sample for a specific language is. So, because we see that the UniMorph is starting being used for estimating morphological complexity of languages. And of course, not all languages are high resource, and not all languages present the same amount of data and the same amount of declension paradigms or conjugation paradigms. So, and in order to understand to what extent we can use that language for certain typological comparison or cross-linguistic comparison, so of course it would be great to provide such kind of estimate. And for instance, like Abela, so that language was derived from this corpus with glosses, and it's highly sparse. So, and it doesn't contain full paradigms at all. So, and finally, this year we started trying with human-like generalization and experiments with wax. So hopefully the next year we'll get more data on the WAG forms. So that's it. So you may also join the project if you like, and we also have a Slack channel. So if you're interested, you may follow us on Twitter or just join the Google group. Thank you so much, and I hope you enjoyed. And any questions?